Okay. Assalamu alaikum warahmatullahi wabarakatuh. And very good morning. In our previous lecture class, we were discussing about equilibrium of particle and three-dimensional forces in the three-dimensional space. Okay. So what is the difference between our two-dimension and three-dimension? Of course, the dimension. Apart from this, direction of. So the ordinary triangular method and parallelogram method will be difficult to apply. In the case of three-dimension. So for that we have to go for Cartesian vector method and unit vector concept. Okay, we will consider the position difference and unit vector concept to find out the forces in the three-dimensional space. So if you remember the problem which we have solved, first we will find out the position vector. Then from the position vector concept, we will find out the unit vector. Then we represent the force. So if you have a system of forces in three-dimensional space, it cannot be obtained by our parallelogram law and triangular law. It will be very complicated. So in order to simplify it, we go for Cartesian vector concept. Okay. And one of the simplification process is dot product, using dot product. Using dot product, we can find out the angles between the two vectors. See, if it is a coplanar system of forces, it will be easy to imagine and find out the angles between the two vectors. If the vector is existing in a three-dimensional space, it will be difficult to imagine the angle and find out the angle. So what we do is, we will be using the concept of dot product. Okay, so it is used to find out the angles between the two vectors. And suppose if you consider two vectors A and B, we have two vectors A and B. So the dot product of the two vectors A and B is defined as the product of its magnitude AB. Okay, you know this arrow mark indicates the vector. Okay, A vector dot B vector equals to AB. Without arrow, it means the magnitude only. So AB cos theta, cosine of the angle between the two vectors. Provided the angle should be within 0 and 180. It should not be more than 180. It can be between 0 and 180. So the dot product will be a scalar product because we know A is a magnitude, B is also magnitude, cos theta will give you the scalar quantity. So the dot product of the two vectors will be a scalar quantity. And the dot product is commutative. A dot B equals to B dot A. Okay, either way you can put it. And when you multiply the dot product with a scalar, it can be written like this. For example, A multiplied by A dot B, A vector dot B vector will be small a n, lowercase a, and A vector dot B vector, or it can be the other way around. And if you consider the distribution law, A dot B plus C will be A dot B plus A dot C. You can write like that. So this is about the dot product. Mainly, it has got two applications. Suppose if you want to represent our Cartesian vector with the dot product, for example, I, J, K are the unit vectors, Cartesian vectors acting along X, Y and Z. Okay, unit vector. Unit vector means the dimension, the magnitude is unity. It's a dimensionless. Its magnitude is unity. Okay. So if you consider I, J, K are the three unit vectors acting along X and Y, and similarly we can find out I dot I. The dot product of vector I dot I will be its value is 1, magnitude is 1, so 1 into 1 times cos 0, because the actually angle between I will be 0, so we take the value as 1. Similarly I dot J, the cos is 90, angle is 90, so it becomes 0. So you remember that I dot I is 1, J dot J is 1, and K dot K is also 1. The other dot products. The different vectors I dot j, I dot k and j dot k will be 0. Okay. So if you apply it for finding the values of two vectors a and b, if you represent the two vectors in the Cartesian form as axi plus ayj plus azk, and the dot product of the two can be found by applying the same concept. So you know I dot I is 1, whereas the I dot j and I dot k are 0. Similarly for the other y and z also. So we will get finally ax bx plus ay by plus az bz as the dot product of two vectors if you represent the vectors in the Cartesian form. Mainly we have two applications for dot product in our engineering mechanics course. The angle between the two vectors can be found like this. So a dot b can be written as ab cos theta can be found, and this theta can be found by taking the cos inverse. Okay. Similarly, suppose if you want to resolve the given force into two components, parallel and perpendicular components, we can find out the two components by using the same unit vector concept. Say vector A, you have this vector A is to be resolved into two components. This is the parallel component, this would be the perpendicular component. The angle between the parallel component and the given vector is theta. Okay, so this is similar to our projection of lines. Projection of line, if you take what do you call in the first angle projection, we follow first angle projection. So the dimension will be similar to our parallel vector component. So this will be the magnitude. The magnitude is given as a cos theta. This is adjacent side. So adjacent side will be a cos theta. And if you consider the vector representation, so a cos theta times u vector. Similar to, if you remember the coplanar forces, you have two forces. This is the given force. We resolve it along x and y, provided this is theta. So this is Fx, force Fx. This is force Fy. Okay. So how will you resolve? The resolved component Fx will be F cos theta. Okay. If you consider this is I and this is j, we write it as I. So the vector representation is not altered, whereas this is the scalar part. Okay. Similarly, Fy can be written as F sin theta times j vector, unit vector. So the same concept is used here. Instead of F, we have A. That's all. A parallel vector will be A cos theta times I vector. Or you know, A cos theta is cos theta. Cos theta is our unit vector. Unit vector. So we write it as unit vector times unit vector. A dot unit vector times unit vector. Why I am telling like this? You can find out, say for example, you have A and U, unit vector like this. This is the theta. Okay. So A dot U will be A cos theta. A dot U will be equal to unit A cos theta. Are you listening? So if you same dot product concept we apply between vector A and unit vector. Vector A and unit vector if you apply, this A dot U will be equal to A1 cos theta. A is the scalar magnitude of vector A and 1 is the magnitude of unit vector cos theta. So we write A cos theta as A dot U. A vector dot unit vector. Okay. That is how we got A dot U as I have already mentioned here also. So A dot U as A vector dot A times 1 times cos theta. So perpendicular component This is the perpendicular component, so it will be opposite side. It will be A cos theta times J. Right. A sin theta J. How will you find out the magnitude of perpendicular component? That is A sin theta. If you know theta, you can find out A sin theta, or you can use Pythagoras theorem. You can use Pythagoras hypotenuse, you know. Hypotenuse, magnitude of the hypotenuse, you know. Magnitude of the opposite side, adjacent side, you know. You can apply the Pythagoras theorem. So A perpendicular, magnitude of A perpendicular is root of A square minus A parallel square. Okay. If hypotenuse is to be found, we will add the two squares of the adjacent side and opposite side. Here hypotenuse is given and parallel side is given, perpendicular is to be found out. We again use the same Pythagoras theorem and we can find the magnitude of perpendicular component. Or you can use theta also. If you know sin theta, you can find out A sin theta as magnitude of perpendicular component. So in this A parallel vector, the first is the magnitude, the second one is unit vector. Okay, so this A cos theta is the magnitude of A parallel vector, A sin theta is the magnitude of A perpendicular vector. And this unit vector we multiply in order to preserve the vector representation. So the dot product will be useful in finding the angle as well as resolving the components parallel and perpendicular to the given axis. For example, we have a problem. So there is a system of cables. It is subjected to a force of 300 Newton. We have to resolve this given force parallel to the cable AB. Figure visible? It's small, Here it is. So in this example, we have a force given in the vector form, unit Cartesian vector form, 300J. So it means it is acting along y direction, parallel to y direction. So 300J Newton is the force. We have to resolve this force into two components, parallel and perpendicular to AB. Parallel and perpendicular to AB. So this is the given problem. So the first step is to find the position vector of AB. Because if you resolve it and if you want to represent it in the vector form, you should know the position vector. Then if you remember the problem which we did in our previous lecture class, first we have to find out the position vector, then unit vector, multiply the magnitude by unit vector, you will get the Cartesian vector form of the particular force. So this force F is 300J Newton is the given force. We resolve it into two forces parallel to AB and perpendicular to AB. So first we find out the position vector for our AB. So we have to find the coordinates for A and B. So what is the coordinate? A is in the origin. B, coordinate for B you can find out. This is x direction 2 meters, y direction 6 and z direction 3. So 2, 3, 6. 2, 3, 6. So if you see here, so this is the position vector or AB. Position difference between points A and B. So that RAB is given by 2I plus 6J plus 3K, and in order to find the unit vector, we divide it by the resultant or magnitude of the position vector, which is written as root of the corresponding ijk components, 2 square plus 6 square plus 3 square. So we got the unit vector. We got the unit vector. In this unit vector, each component represents cos theta, cos gamma, that concept. So we multiply the force FAB by F cos theta. Okay, so we will get 300J times the unit vector. This cos theta represents our unit vector from our previous slide. If you remember the dot product concept, so F dot U will be equal to our FAB. Okay, so FAB is the resolved component. So 300J dot your unit vector. So we find, since the I component is not there, we finally get 257.1 Newton as the magnitude of FAB. This FAB is magnitude, okay, not before. Now, in order to find the force, we multiply the scalar part with the unit vector. So 257.1 is multiplied by the unit vector, which we found from our first step. So we got the force FAB in the Cartesian form. And you can find out the perpendicular force by just considering the vector subtraction, because FAB parallel plus FAB perpendicular will be our resultant vector. So we subtract the FAB parallel from our resultant vector, given force vector. So we will get 300J minus the FAB will be our FAB perpendicular component. In order to find the magnitude of FAB, we use the Pythagoras theorem, or we can go for finding the theta also, and we can get it the other way. So first step in this problem, if you want to resolve the force into two components, first we find the position vector for the particular line along which you have to resolve, then get the unit vector. After that, you get the scalar for that FAB. The scalar for FAB is obtained by using dot product, F dot U, okay, F dot U. Then after getting the scalar, we get the vector form of FAB. Also, we can obtain the perpendicular component by subtracting it from our, by using the subtraction, vector subtraction. Also, the magnitude can be obtained. So like this, the dot product concept can be used. I will explain one more problem, then you can take down. Say you are given a pipe. The pipe is fixed to the wall. It is acted upon by some force of 80 Newton. Okay, so you are asked to find out the components of the given applied force parallel and perpendicular to the pipe AB, the segment, pipe segment AB. You have to find out the components parallel and perpendicular to AB. So first, as usual, we have to find the position vector for AB, and because the force magnitude is only given. Okay, so first we convert the given force into Cartesian form. So to convert it to Cartesian form, we should know the position vector. We should find out the unit vector form. We should find the unit vector, multiply the unit vector by the given magnitude, we will get the Cartesian form, isn't it? So we have to get the unit vector for BC as well as unit vector for AB. That is the first step. So position vector for AB is found, position vector for BC is found by considering the coordinates. So we have to resolve it like this, parallel and perpendicular to your AB. So first we find the position vector for AB considering the coordinates for point A and B. So you are given the dimensions for point B as well as point A. You can find out the coordinates. After getting the coordinates, the position vector is obtained for AB, position vector for BC is obtained. Then unit vector. This cos theta is nothing but our unit vector. So RAB by RBC we will get theta. So from angle can be found 42.5. So the angle made by the given force with respect to the resolving axis is found first. After that, we have to resolve it. So unit vector is obtained. RPA by RPA, the vector RPA, position vector RPA by the magnitude RPA, it will give you the unit vector. Then we multiply the given unit vector with we get the unit vector along BC also, the vector along BC also. The same step is repeated here. So we got the vector along BC. So FPA, we can write F dot UBA, the magnitude dot UBA, for dot products of force F and unit vector BA. So we got the magnitude for FPA. So magnitude for FPA can also be found using theta. Cos theta concept. Okay, so F cos theta is 80, cos 42.5, this is also 59. So perpendicular component can be used. Theta is known, we can use F sin theta and find the magnitude of perpendicular component. So we apply the dot product concept to get the unknown angle as well as resolving the two forces. The application is completely illustrated in this problem. Okay. So the first step is to find the position vector. After finding the position vector, if angle is not known, like this problem, angle is not known, so we find the angle by using the dot product concept. We consider the dot product of two position vectors. It can be any vector. Okay, in order to apply the dot product and get the angle, you can consider, it need not be the force or it need not be the given vector, you can consider the position vector. In some problems, even you can consider the unit vector along AB, unit vector along BC, like that. Unit vector can also be considered and find the angle. Okay, so angle, the magnitude may change, but the angle can be found. So we have considered here the position vectors between AB and BC to find the theta. After finding the theta, we apply the concept of dot product again to find the forces parallel and perpendicular to the two given axes, to required axis. So you can take them. Any doubt you can. So after drawing this, first find out the coordinates. Coordinates for A is 0, 0, 0. It is in the origin. Coordinate for B. Yeah. Position vector for A is 0i. Position vector for B. Now RAB. Is R3 minus RA. So like that we will find position vector between point A and B. Position vector for A, position vector for B, then RAB is RB minus RA. Okay. So after finding our position vector AB, we find the unit vector along AB. So we find the unit vector first, then scalar AB first, next, then vector AB. Vector AB is parallel component, okay, then perpendicular component. So in 4 steps. First position vector, 0th step, then unit vector along AB. Okay, in order to represent FAB in terms of Cartesian form, first we will find the unit vector. So unit vector, then using your dot product concept, we find the scalar for AB. Scalar along force line AB. Scalar for force along line. So the force F has got only Y component. There is no I and K component. So it is taken as 0. So the first component is for force. Force F has got 0I and 0K. Okay, 300J. So force is I component multiplied by unit vector I component. Then force J component multiplied by unit vector J component. Like that. So the 0 in the first and last term refers to the 0 I and K components of force, which is 0. Because force is acting along Y, acting parallel to Y. So there is no I and K component for the given force, 300 Newton. See, maybe the cos theta term, if it is confusing, you can neglect it. Actually, we consider, in order to find the scalar of AB, the scalar AB can be written not known. The magnitude of AB is not known. For that we use the dot product concept. So this is the given force, 300 Newton. Okay. So we have to resolve it into two components. So this line is parallel to the cable AB. Okay. This is B, this is A. Parallel to it. So we have to resolve it into two components. So we consider FAB, the force acting along AB as scalar AB times its dot product. Scalar AB times the unit vector. Scalar AB. I have not shown the arrow, that means scalar. Scalar AB times unit vector. Okay, we can write it like this. That is what it is here. Okay. So this. Now we take this as UAB acting along AB. We consider the dot product of these two. So dot product of these two will be your F times U. Okay. F dot U. So you will get a magnitude for FAB. Magnitude for FAB. That's also we use dot product concept to get FAB. So this is scalar AB times its dot product. Scalar AB times unit vector. So unit vector and the given force vector is considered and its dot product is used here to find the magnitude FAB. So after finding the scalar, then we find the vector that's perpendicular. Okay. There is the next problem. Even if you don't understand, you go to the dot product phase. You can, what you note in A vector, that's the phase. So A vector times the dot product of your A parallel vector. Point B is 3 meters only. Point. So what is the coordinate for A? 1. A coordinates for point A. See, the x is 0 and z is 0. 0, 0, 1, 0. So the y distance is 1 meter. Okay. It is along y. Along with y oda same irukku. So adala x1 is at 0 ஆகும். y க்கு மேலயோ இல்ல y சைடுலயோ இல்ல. y லே அந்த போர்ஷன் ஒரு பார்ட் வந்து பெண்ட் y லே வந்து அதுக்கு அப்புறம் பெண்ட் ஆகும். So அதனால x 0 வரைக்கும் z 0. y ல எவ்வளவு டிஸ்டன்ஸ் இருக்கோ அது மட்டும் நமக்கு 1 மீட்டர். 0 1 point B point B x 2 meters y y 2 3 and coordinate capital B coordinate x was 2 meters along the height x y distance was minus kilo z வந்து கீழே போகுது. So Z minus 1 கீழே y upward positive Z வந்து upward y வந்து right side positive x வந்து front வந்து positive lower side positive or so 2 3 minus 1 2 3 and minus 1 are the coordinate for point C. Now write the position vector Z வந்து கீழ இருக்கு. Z வந்து distance is இந்த bend வந்து கீழ இருக்கு. That is height 1 meter. Okay, so if force F உடைய magnitude மட்டும் தான் கொடுத்திருக்கு. Force acting along BC உடைய magnitude மட்டும் கொடுத்திருக்கு. But we have to find out force along AB, perpendicular parallel AB கண்டுபிடிக்கணும். So ரெண்டு first வந்து இந்த force ஐ Cartesian form convert பண்ணணும். Force BC ஐயும் first we have to convert it into Cartesian form. Convert பண்ணனும்னா அதனுடைய position vector கண்டுபிடிக்கணும். So find the position vector along BC. RBC கண்டுபிடிக்கணும். அப்புறம் RAB கண்டுபிடிக்கணும். RBC யூனிட் வெக்டார் கண்டுபிடிச்சு அதை மல்டிப்ளை பண்ணோம்னா force along BC is 0. அப்புறம் force AB. So first step position vector along BC. Point C உடைய coordinate 2, 0, smart board C 2,0,0. X ல வந்து 2 meters இருக்கு. Y on x coordinate. The point C is on x coordinate. So x coordinate ல ஒரு பாயிண்ட் இருந்துச்சுனா it is like a point on between A என்ன சொல்லுவாங்க projection like projection of points போது அது போல. So your x and y and z become 0. If it is on x coordinate, your y and z 0. If it is on y coordinate, the other two will be 0. Okay. அதனால தான் point A க்கு வந்து x and z 0 ஆயிடுது. Point C க்கு வந்து y and z 0. டைரக்டா ஒரு ஸ்டெப் ஸ்கிப் பண்ணிடுங்க. ஆக்சுவலா RA RB அது மாதிரி போட்டீங்கன்னா புரியும். ஃபர்ஸ்ட் ஃபைண்ட் அவுட் பொசிஷன் வெக்டார் ஃபார் பாயிண்ட் B, பாயிண்ட் A, பாயிண்ட் C, தென் அதோட டிஸ்டன்ஸ். ஃபர்ஸ்ட் ஃபைண்ட் பொசிஷன் வெக்டார் ஃபார் பாயிண்ட் A. பாயிண்ட் A உடைய கோஆர்டினேட் என்ன? 0, 2, 0. This 0, 2 தானே 1. Point B க்கு what is the coordinate for B? 2, 3 minus 1. Point C 2, 0. Okay, so RA is 0I plus J plus 0K. RB 2I plus 3J RC 2I plus 0J. Now find out RAB. RB minus RA. So that's what is written there. Okay, RBA, RBA. along BA கேட்டிருக்கேன். ரிசால்வ்னா it will be the tail வந்து இங்க வரும். A RBA RAB என்ன வித்தியாசம்? tail உடைய position. If you say RBA, B is the tail end and A is the head. A is the head end. Okay. So vector sense is also important. In the sense, if the direction sense will be negative, means it will be different. So we write it as RBA. That is why we get negative sign for RB. Minus 2, minus 3J, minus 2J. So single force is okay. Now several forces and the data. First step, for a step and repeat I have to cut it. The F one acting along this force acting along this. இதுக்கு FBA அதுக்கு ஒரு force எல்லாம் அது force plus FBA க்கு அது corresponding இருக்கு. F வந்து actually FPC. Okay? UBA UBC ஆமா okay UBC அத ஃபோர்ஸ் நமக்கு தெரியும் FBA தெரியாது FBA உடைய வெக்டார் தெரிஞ்சதுக்கு அப்புறம் நீங்க வரும் RBA தெரிஞ்ச Okay, now Yes, sir. Got it, Lama? So now we are going to apply whatever we have studied, forces in 3 dimensions for finding, for checking the equilibrium of particle in space. Equilibrium of particle in space. Okay. So for that, sigma f equals to 0. For any particle is in space, your sigma f will be equal to 0. Sigma f will be equal to 0. That means your sigma fx, sigma fy and sigma fz will be equal to 0. All the 3 components along x and y, x, y and z will be equal. Consider we have 3 forces, F1, F2, F3. So 3 forces will be in equilibrium. Sigma f, summation of all the forces equal to 0. So in order to check that, we resolve the 3 forces along x, y and z. X, y and z, we will separately see whether sigma fx is 0, sigma fy is 0 and sigma fx is 0. Okay. Then we will say the system is in equilibrium. So sigma f is 0, that means sigma fx, sigma fy and sigma fz should be equal to 0. Okay. So we apply this in order to find the unknown forces. Okay, we can use the dot product concept or angle concept, but we use the equation of equilibrium to find the unknown forces in a system. The equilibrium principle is generally used to analyze any system of forces, whether it may be coplanar system of forces or forces in 3 dimensions. We use the equilibrium of particle concept to find the unknown forces or to analyze the forces, system of forces. Whether the force will be very heavy or it will lead to failure, all these things. Now we will see one problem. So we have now a system of force. A particle is acted upon by many system of forces, F1, F3, F2, and there is a force along B. Okay. So we have to find out the force F. Force F is here. So this force F, the magnitude and direction plus angles of the force F is to be found out considering the equilibrium of the particle. It is said that the particle is in equilibrium. Okay. So considering equilibrium of the particle, we have to find out the forces, unknown force F. So this is a given system of forces. So each force can be expressed in the Cartesian vector form if we know the position vectors and coordinates. Okay. So we know that here F1 is acting along Y. So it will have only J component. Okay. So we can write it as 400J. Similarly, F2 is acting along Z, but in the negative side. So it is minus 800K. Okay. Whereas this F3 is here, F3 is in this place. So we have to consider the coordinates of the force acting along OB. Okay. We have to find out the position vector along AB, then find out the unit vector, and we can obtain 700 magnitude of the force times the unit vector will be the Cartesian form of the force along OB. So for that we are given the coordinates. The 2 meters, it is to the left of Y. The height is 6 meters. Okay. So we can find out the point B's coordinates and we can apply, and the Cartesian form of coordinate force F3 is now known. Now we just add the Y components. So this is the total force. It is sigma F, summation of all the forces means if you add all the components it will be like this, also including the unknown force F. Okay. We have added the I, J components of the given forces. So using the equilibrium equations, sigma fx equals to 0. So we find minus 200. The I components. Okay, I component is the fx component. So we get fx as 200. Fy can also be found, and fz can also be found. So if these are if it is in equilibrium, the remaining part, so unknown force is known. So we can write it in the IJK format, and direction coefficient can be obtained using the unit vector concept. UF equals to F by F or 300 that force divided by the scalar. So 200I divided by 300 the magnitude of the force. So we got alpha, beta and gamma. So we apply the equilibrium of equilibrium concept and find the unknown force after resolving it into the components. So first we have to resolve them, or first we have to consider the three ij Cartesian vector form. We have to write the given force in the Cartesian vector form. So if you write it in the Cartesian vector form, it will be simple to add the components along x, y and j and find the unknown force. Okay. So that is okay. Coordinates for B, B உடைய coordinates தெரியும், அதில் இருந்து position vector, unit vector. So that is the next step. We have separated x, y and I component is fx. Okay, j component is fy and k component is sigma fx, sigma fy, sigma fz is equal to 0. So find fx and fy and represent it in Cartesian form. Get the magnitude. Root of fx square plus fy square plus fz square will be the magnitude of the unknown force. Okay. And this angle can be found by using unit vector concept. Cos theta, alpha beta. So after finding the fx, fy, fz, we will write it in the Cartesian form and its magnitude can be found fx square plus fy square plus fz square. Then find the unit vector, use the unit vector concept to get alpha, beta, gamma. Because the unit vector represents cos alpha I plus cos beta j plus cos beta k. If you remember the unit vector portions which we have dealt with last class. So this unit vector can be used to obtain the direction cosines. Okay. So this is the equilibrium of particle in space. We can solve the unknown forces. We can find the unknown forces by using equilibrium of particle in space. We have one more portion left, that is moment of the forces and equivalent system of forces, that we can see in our next class.